My name is John Clark, and this is sentiment analysis of Twitter data prepared for the Harvard Extension School Spring 2015. Can the text of specific tweets be programmatically parsed to discern the overall mood for various topics? Well, the topic I chose was Major League Baseball. Three teams in particular, the Boston Red Sox, the New York Yankees, and the New York Mets, all three of which have a significant fan base in the New England area. I created a Twitter application to gain access to the Twitter API and the Twitter data. I used R, or more specifically Twitter R package, to obtain 10,000 tweets for each of the three hashtags. I parsed each tweet in R and obtained a sentiment score and an associated histogram. I have a second algorithm for scoring based off the first, but a little bit more detail on retweeting and favorite counts, and I implemented that using Hadoop MapReduce. I exported that data back out of Hadoop, back into R, and I compared the different scoring methods. But what is sentiment analysis? Well, it's computationally determining the mood or an opinion of a piece of text. In our case, it's the 140 characters that we call tweets. One approach you can take is to define a dictionary of both positive and negative words. And you can see on this slide here that I've sort of listed a snippet of each of the word sets that I've used. It wasn't a lot of words, but it was enough to sort of get the point across. The challenges to this are that you don't know if the user is going to be sarcastic. So when you're scoring the tweet, you're basically counting the words. How many of these positive and negative words occur in the tweet? And you just sort of count them up. 1 point for positive, negative 1 point for negative, and you get an overall score. So if you have 3 positive words and 5 negative words, that's an overall -2 for its sentiment. But if the user is being sarcastic, you don't really know. Maybe their score comes out like a +5, but they were being sarcastic, and so you should have interpreted it as a -5. That's difficult to do with the dictionary approached method. Another problem that we have is, what if the user misspells a word? If the word is misspelled, we can account for some misspellings, some common misspellings in the list below. As you can see, we have here in the word accessible. However, if the user spells it significantly wrong, it won't hit our dictionaries. Another problem we have is that when it comes to Twitter, you only have 140 characters, and so it's very common, in fact intentional, that users will abbreviate certain words so they can get more of their thought in under the 140 character limit. It would be very difficult to include all of those permutations, although some of them can be included. It would also be difficult if the user is using a mixed language or not even in English at all. In the case of baseball, there are many Latino players, and so Spanish tweets about these three teams are actually quite common and would not hit our dictionaries. So some challenges in using this approach. The first approach to scoring was, as I've just described, the simple count of positive and negative words. This was based on Jeffrey Breen's work, mining Twitter for airline consumer sentiment. He, as well as I, used R to analyze and to apply this algorithm. The second approach was my own formula, and it gave more weight to tweets that are retweeted or favorited. The original score from approach 1 is multiplied by the number of times that that particular tweet is retweeted. I felt this was appropriate because when something is retweeted, it sort of has a multiplying effect going out to greater and greater numbers of users. When a tweet is favorited, it doesn't actually do that, but it does bear a little bit more weight than a tweet that perhaps didn't become someone's favorite. So we simply add that into the overall score. So if it was a net negative score, the favorite count would move it even a little bit more negative. If it was a net positive score, then it would move it a little more positive. I chose to do this analysis using Java and Hadoop MapReduce, not because I had to, but because I thought it would be interesting to kind of see how Hadoop could play a role in this type of analysis. But I could have just as easily done it in R if I had wanted to. And so at this point, I want to skip out of the presentation. I want to go over to R, and I want to show you some of the code that I was executing. I've already executed a bunch of code that's kind of above here, above line 30. I don't want to show it in this presentation because it does contain some of my Twitter secrets that I wouldn't want people to be able to use to get access to the Twitter API in my name. And so I've already executed that code. I've already made a connection to Twitter in terms of OAuth and connecting to their API. Twitter requires every access to it to be authenticated through OAuth. And so I've already executed grabbing these two 10,000 tweet data sets. I'm going to show you grabbing the Mets data set. I'm only grabbing 100 tweets in this particular case because I don't want it to take too much time during our demo, but you see it came back fairly quickly. And now what I'm going to do is I am going to extract this data that we've generated so that I could include it in my submission. You can see it's quite simple. I'm just taking the text, taking the favorite count, and the retweet count. These three pieces of information are important in my second scoring algorithm, and so it's probably pretty obvious why I'm seeking to grab that particular data. It's worthwhile to note, though, that the amount of data that is included with Twitter, with each tweet, is actually quite large. You can see if I extract the text here, it only comes out around 985K. But if I try to scroll up just a little bit here, if I can grab it, you can see the entire Yankees data set is 6.2 megabytes. And so if I were to export all the information for each tweet, it would be quite large. I only chose to export down below the text portions just for submission in with my submission for this project. But there is quite a bit more data in there that is being parsed in this algorithm. Here I'm exporting the data. This allows me to include it into other analysis tools. The next step I'm going to do is to read in the positive and negative word lists. These word lists were obtained from the internet, and maybe, I don't know, 800 to 1,000 words each. You can see the counts coming up here, the character counts. And this allows us to sort of create a dictionary from which we can do our analysis, the scoring approach number one. The next thing we want to do is to load our scoring algorithm into R, into the memory of R, so that we can sort of execute against it. And this was taken from the sources listed right here, Jeffrey Breen's work. And I will load that into R and run it. So I did make some adjustments here. It's not all copied. For example, one of the things that I did was I did some data scrubbing here. I noticed that whenever there was tweets with special characters in it that were not alphanumeric, it sort of messed up this algorithm. So here you see I'm scrubbing it and making sure nothing can make it through and mess up this algorithm at all. The next thing I want to show you is I want to show you the scoring of it. Here I'm going to take the Red Sox tweet texts and run them through our scoring algorithm. You can see here it's called score.sentiment, applying the list of positive words and the list of negative words against the set of Red Sox tweet texts. Now I can create a very simple histogram where you can see that the sentiment for the Red Sox, at least in the data that I just grabbed here, and for this demo I grabbed data that was a little bit different than the ones that I submitted in my report, but you can see that the sentiment for the Red Sox is basically neutral, maybe slightly positive on this particular day, perhaps because they're winning a little bit more as of late. And if I do the same thing for the Yankees, we'll see what they come up as. You can see the sentiment for the Yankees is fairly tight, fairly neutral, maybe slightly negative for the Yankees. You can see the distribution on the Yankees actually isn't that large. It only goes out to maybe -4, +3. I actually didn't look at the Red Sox one. A little bit more spread out for the Red Sox. And now when we move down to the Mets, it'll be much different because we only have 100 data points here. So you can see that the occurrences are a lot lower. But again, the score is basically neutral. Now, what I can do now is I want to export this data because I want to be able to employ the second scoring method, which factors in the retweets and the favorites. And that's why I'm exporting into a data frame here the original score in the first column, the retweet count in the second column, and the favorite count in the third column. And so I'm going to write that to a table for the Red Sox, and then I can grab the Yankees and the Mets and write them to their own file. And at this point in time, we're going to go out to Hadoop and to observe the second scoring method. Then we'll come back and we'll actually generate a histogram for these guys. But now I want to go out to my VMware, there it is, to my VMware and show you the application of Hadoop. I have I already moved the files over just to make the demo a little bit quicker. You see I'm in a file they created here called homework 12. You can see in here I've got the jar file. I've got my various input files. In here I've got a little bit of, I've got some output here from a previous run, but you can see that I have the 3 input files that I'm trying to produce: Mets 10K, Red Sox 10K, and Yankees 10K. I will just show you what is in Hadoop. In the directory where I'm going to, you can show that I've actually moved these files over into the Hadoop directory. And then I want to make sure that I run the code here now. And you can see Hadoop is running, executing my MapReduce. I can show you the code in just 1 minute, but you're going to see the MapReduce run. It doesn't take too much time. It's very efficient on a large data set. You're running it. And in the meantime, while that's running, I'm going to go over to Eclipse, load that up to show you the actual code that I ran. You can see there the map phase is done. Moving on to the reduce. You see there it completed. So actually, well, when you just look at it, since we're here, I can now we can see that we actually have output success, and I would just show that there just to kind of give a glimpse of what the output looks like. You can see in the first column is the actual score, and in the second column is sort of the histogram, if you will, of occurrences of that score. So for example, we had 100 tweets that had this, I should say 96 tweets that had the score of 100. And you can see as we scan up here, you can see as we expect, the majority of tweets will be around 0, since 0 times anything would be 0. So the retweet count wouldn't really factor into something that was neutral. And so you can see the output of that. But what was the code that actually ran here? We can show you here. There we go. And so in the MapReduce code, the map section is applying the algorithm. I'm just gathering the score and the tab position so I can parse out where the retweet and the favorite text begin. So now when I get down to this point, I have the score, the retweet, and the favorite value set. I take the score and I multiply it by the number of times it's been retweeted. Obviously adding 1 because you wouldn't want to zero it out on something that was never retweeted. And then once I figure out if the score is net negative, I would subtract the favorite count. If it was net positive, I would add the favorite count. And that's the basic map step where it's applying the formula. In the reduce step, it's basically just doing a simple tally of all the counts and then exporting that with the key as the key. Now when we go to our results, in the presentation that I produced for the class, you can see the results side by side very nicely. And here for the Red Sox, you can see that there was, in general, a neutral score, maybe slightly negative the time that I ran this particular analysis. But then when I did the second scoring method, you can see how it was sort of basically the same, maybe a slightly more positive. The Red Sox tweets didn't seem to have as compared, you'll see in a minute, didn't really seem to have a lot of retweeting. The Red Sox had just actually played the Yankees, their arch rival, and the Yankees had beaten them 3 straight games in the Red Sox stadium, and so it was definitely a demoralizing time for the Red Sox, and so it seems like they don't have a whole lot of positive things to say, still sort of a neutral reaction. And I did notice in general that things that are negative don't tend to get retweeted, which I thought was really kind of interesting. It's really the positive things that are said in Twitter that seem to be retweeted. And so since the Red Sox didn't have an abundance of the positive, I didn't see that the retweet count was very high. Now let's compare it to the Yankees score. We see something a lot different. The Yankees had basically a neutral score, maybe slightly positive to begin with. But then when you factor in the second scoring method, you see a dramatically different result. You can see there's a lot of retweeting going on, and the Red Sox only had something out around the 400 mark in terms of a score. But you see the Yankees have all the way out to 1,500. So there's a lot of retweeting here. Obviously, a lot are happy Yankees fans that they just beat the Red Sox in 3 straight games. And so you see the dramatic shift. Lastly, we see the Mets, and we see that the Mets score here, basically neutral, maybe slightly positive, arguably. But then when you factor in the retweet, you definitely see a shift toward the positive. Not quite as large as the Yankees, but you see the retweet counts are higher. Probably the retweet counts aren't super high because, let's face it, I mean, who really is a Mets fan anyway? Are there any of them out there? I'm not sure. But, you know, you see a slightly more positive result when you consider the retweeting action from the Mets. Now, the Mets are having a really good season, and so obviously their fans are probably pretty happy about that. And so you don't see a whole lot of negative down here, which is also very interesting. Now, when it came to challenges, Twitter kind of presents a few challenges. One of them is that historical tweets are not easy to get. Twitter themselves offer a 7-day rolling window access to their tweets, but once your target time frame is out of that 7-day rolling window, you've got to rely on some of the other vendors who are sort of collecting tweets from the Twitter fire hose, as they call it, just the massive stream of tweets that are going on at any minute. And so you sort of have to plan ahead. And originally I was thinking maybe I would analyze the tweets in the Boston area around the snowstorms, the snowmageddon, different things that were going on. But that proved to be really difficult because I didn't want to shell out the money to actually purchase those tweets. And other users were warning that even if I did purchase the tweets, I might not even get the entire set. And so then would my analysis be accurate? So historical tweets are hard. The other thing I was hoping to do was to do some correlation of location data with the tweets, because deep down in my heart, I know that all the negative stuff that's coming out about the Red Sox is coming from the Yankees fans. Everybody knows that, but I really wanted to prove it. And so I was hoping to harvest the location data out of the tweets that were being sent. Unfortunately for me, and fortunately for every Twitter user, you are able to turn off the geolocation feature in your Twitter client. And so you can tweet more kind of geographically anonymous, or you can turn it on. And so when I analyzed the specific tweets for the three baseball teams that I had, it was quickly obvious that there really wasn't a whole lot of location data in there, and so something like this would not be possible. The other thing I ran into is Twitter rate limiting. You can't just bump up your request and try to grab, 10 million tweets on a particular topic, because Twitter will meter you and slow you down, and then it could take a really, really long time. And so that was that was kind of why I chose my 10,000 threshold. So some challenges there. So basically the technology I was running on a MacBook Pro, different software I used, RStudio, Eclipse, Luna, VMware Fusion. I used the Cloudera Quick Start VM 5.3 that we used in our homework assignments, and I ran it on Hadoop 2.5. So in general, I found this project very interesting. There'd be definitely some more areas I would want to look into, and I also think there's a great deal of opportunity for monetization of this type of sentiment analysis.